Evaluating the 6 trigonometric functions using the unit circle. The unit circle is a circle centered at the origin of a coordinate plane with a radius of 1. This circle can be used to solve many trig functions if it is used correctly. We can first split up the circle into 4 parts, where each section is in a different quadrant on the coordinate plane. The circle begins at the point 1, 0, where the degree of the central angle is 0. Then, at the point 0, 1, the central angle measures 90 degrees, or pi over 2 radians. The next point, negative 1, 0, makes a straight central angle, which means the measure is 180 degrees, or pi radians. Lastly, the point 0, negative 1 has a central angle measure of 270 degrees, or 3 pi over 2 radians. The circle can be further split up, where each section either measures 45 degrees, or pi over 4 radians, represented by the blue lines, or each section measures 30 degrees, or pi over 6 radians, represented by the green and purple lines. If you remember, a 30, 60, 90 triangle with a hypotenuse of 1 has an opposite side measuring 1/2, and the adjacent side equals the square root of 3 over 2. If we look at the line that makes a 30-degree angle in the circle, we can see that it makes a right triangle with the x-axis. We can apply the rules for a 30, 60, 90 triangle and know that the adjacent side, or x value, equals the square root of 3 over 2, and the opposite side, or y value, equals 1/2. A 45, 45, 90 triangle, or an isosceles triangle, has 2 congruent sides. If we remember that one side equals the square root of 2 over 2, we know that the other side must be equal to the square root of 2 over 2 as well. Eventually, if we use what we know about circles in the coordinate plane, our unit circle ends up looking something like this. The values for each opposite line is the same. The only thing that changes is the signs as we change quadrants. We can now use the unit circle to determine the 6 trig functions. Let's say we are given the problem sine of pi over 3. First, we must find the angle pi over 3 on the unit circle. We know that sine is opposite over hypotenuse, and the opposite side is equal to the square root of 3 over 2. And anything divided by 1 is itself, so the sine of pi over 3 is equal to the square root of 3 over 2. Cosine of pi over 3 is equal to the x value, 1/2, for the same reason. The adjacent side is 1/2, and that divided by 1 is equal to 1/2. Tangent is the opposite side over the adjacent side, which means we must divide the square root of 3 over 2 by 1/2, or multiply by the reciprocal 2 over 1, which gives you the square root of 3. We know that cosecant, secant, and cotangent are the reciprocal functions. So cosecant of pi over 3 is equal to the hypotenuse, 1, divided by the square root of 3 over 2, or the opposite. Simplified, the answer is the square root of 3 over 2, but you can't have a square root in the denominator, which means you need to rationalize. Multiply both the top and the bottom by the square root of 3, and you're left with 2 square roots of 3 divided by 3. Secant of pi over 3 is 1, the hypotenuse, divided by 1/2. This is the same thing as multiplying by the reciprocal 2, so your final answer is 2. Finally, cotangent is adjacent over opposite. For the angle pi over 3, the adjacent side is 1/2, and the opposite side is the square root of 3 over 2. Multiply 1/2 by the reciprocal, and you are left with 1 over the square root of 3. Rationalize the denominator by multiplying both sides by the square root of 3, and your final answer is the square root of 3 over 3.
Created using Powtoon.